Hello friends, welcome back to my channels and tutorials. I am your teacher Sir Durba here to guide you during this lockdown. I hope that you're following this channel, and if you're following it, if you're liking it, then please do share it with all of your friends, especially those who cannot attend the classes online. Because there can be many reasons for not being able to attend classes online. Maybe some of them, maybe their parents only are using their phones, so maybe they cannot attend the classes at the right time when the others are attending. Some may be having some network problems, so that's why this you can always make use of this channel, where I will be definitely guiding you throughout the course of this, even if this lockdown ends. So I believe that you are doing your studies also well enough. I believe that you are staying safe at home. Please make sure that you stay safe at home. Alright, so till the other previous videos we have already done differentiation based on logarithmic applications. So now today let's move on to another new topic, like how do we derive. There is definitely, as I have mentioned before, there is not going to be new formulas that you will be getting. Okay, just all those same formulas we'll be using, but now we'll be just finding out ways on how to differentiate more complex functions, more difficult functions. So that's what happened with logarithmic differentiation also. We have seen how we can take the help of logarithm to simplify a complex function and then differentiate that. So because functions can be of different forms, isn't it? So this is also one topic that we are going to be studying today, that is how do we differentiate parametric functions. But before that, you have to rewind and go back. What are parametric functions? See, sometimes what happens is you come across two functions, and both of these two functions are represented by another function, or let's say another variable, like cousins, relatives, but not directly, just cousins. So that's what happens, isn't it? Cousins, different parents, but the parents are linked, so you become cousins. So that's almost like a family, isn't it? So sometimes what happens is two functions actually are linked by a third variable. Now that third variable is called as the parameter. So if we come across this kind of functions, how are we going to connect and how are we going to differentiate functions? For example, maybe you have two functions, x and y, and then both of them are represented by another variable t. So in that case, that third variable, that third party, that is called as the parameter. Okay, the third party, the third variable is called as the parameter. Okay, so for example, this function x is represented as f of t, y is represented as g of t. So what do we do? We are going to differentiate this with respect to the parameter only. We have to identify the parameter. That becomes very important. So we have to identify the parameter. So this becomes first order derivative of the function. This also we differentiate with respect to t, so that becomes the function. So now after that, if you want to connect these two functions, what do we do is to find out the derivative of the function y with respect to x. What do we do is a simple concept, that is f dash of d derivative, not f dash, g dash of derivative of the second function, which is derived with respect to t, to the parameter divided by f dash of t, or in other words, y with respect to t, x with respect to t. Remember, t is the parameter here. Okay, so but the parameters can change. It can be theta, phi, any parameter. So your job is actually to recognize the parameter. What is the parameter? The third variable, the third party, the middleman. I would call it the middleman. And then differentiate both these independent functions, which are somehow dependent or related to each other because of the third variable, the parameter. So differentiate both of these functions separately with respect to the parameter, and then combine them with the help of this method. Alright, so it's not a very difficult task for us. So let's continue. Let's just let's just continue. I'm going to say I'm not going to talk much on the introduction, and I'm not going to be talking much on how, what, when, where, why, and all. For that, of course, I will be bringing out other topics, other videos where I will be definitely helping you to prepare for your JEE examinations, NEET examinations, or any other competitive examinations. But now let's focus, as I had told you before in the videos or in my other videos, here I will be focusing more on your board examinations and all. No? So let's go straight to the point. That is the exercises. I will be helping you solve exercises first, okay? And if you need, then definitely I will give you more problems from other textbooks also. Don't worry about that. So let's go to 5.6 straight up. The question is if x and y are connected parametrically by the equations given in exercises 1 to 10, then without eliminating the parameter, find del y by del x. I hope you've got your textbook, your pen, paper, everything ready. I'm just reading it through the textbook. I don't want to be writing all the question again. It's kind of boring. So that's why that part, I've kept it in front of me here, the textbook. So I'm just going to read that through the textbook. Okay? So I read that question again. If x and y are connected parametrically by the equations given in the exercises 1 to 10, without eliminating the parameter को remove नहीं करना है, find del y by del x. First question. Let me start with the first question. X, what is it? 2at square. Y, 8t power 4. 8t power 4. So could you recognize a parameter here? X and y are both represented by, of course, a, it will not be the parameter. Okay, some of you may be confused, but as we know, until and unless it is mentioned, the letters a, b, these are arbitrary constants. These are constants until and unless it's specifically mentioned in the question that okay, these are not arbitrary constants. Okay, these are parameters, or these are variables you have to do. Now, if that is not mentioned, assume this as arbitrary constants only. So here, what is the variable here? T, no? T. So generally A, B, C, D, these are constants. We assume this as arbitrary constants, and the letters X, Y, Z, P, Q, R, S, these are more used as variables. So what is the parameter here? So here the parameter is t. So that's the answer recognized. So then x equal to 2at squared. So I'll differentiate. I'll go straight to the differentiation. This implies I'll differentiate this function with respect to t. So since this is the last part, almost the last part of differentiation and all, let's just go straight to the differentiation. That is 2a constant nikal do bahar, t square with respect to t. Right. So okay, I'll just write here. So 2a differentiation of t square will be 2t. So this becomes, that means del x with respect to t is 4at. You can mark that as equation 1. Right? You can mark that as equation 1. Done? So chalo, let's go to the second function y, and y equal to at power 4. So this is, now we'll differentiate this also with respect to the parameter a constant, t power 4 with respect to t. So what do we have here? So that's a for t cube. So that's going to be 4at cube. Right. So you can mark this as equation 2. So now you can see that both the functions x and y are represented with respect to the parameter t after its first derivative. So now what we will do is, now y with respect to x. Let's find out that. That's going to be y with respect to t, x with respect to t. So what was y with respect to t? 4at cubed. X with respect to t, 4at. So what is the ultimate solution? Find out quickly. Chalo, quickly find out the solution. Did you get it? So what is the solution there? That's going to be what? So the solution, I guess, that's going to be like 4a cancel, that's going to be like t square. Isn't it? No, 4a gone, t square. Alright, so it's simple as that, okay? So, as I said, no new like formulas and all, just the same old differentiation theorems we were using, applications only. But the process, how do we differentiate parametric functions? Like this, okay? Alright, let's do some more question. कौन सा करेगा? चलो, question number 2. X equal to a cos theta, y equal to b cos theta. So now tell me, what is the parameter here? What is the parameter here? What will be the parameter? The parameter is going to be what? Theta, isn't it? Theta. So x equal to a cos theta. Did I write down the question correctly? So yeah, a cos theta, b cos theta. Chalo, no problem. A cos theta, b cos theta. So let's differentiate. Of course, write down here the parameter is theta. So x equal to a cos theta. So we will differentiate this with respect to theta. So a constant, derivative of cos theta with respect to theta. What do we get? Minus sine theta. So that's minus a sine theta. And y equal to b cos theta. Similarly, we are going to be differentiating y with respect to theta. So b constant, derivative of cos theta with respect to theta. So b minus sine theta. So that will be minus b sine theta. If you want, you can mark your equations as equation 1, equation 2. No, that's up to you. Okay. So now let's connect them. Now their y minus x will be y, which you differentiated with respect to the parameter, x, the function x, which you differentiated with respect to the parameter theta theta. So that's going to be, what is y? Second one, okay. Minus b sine theta. First one, minus a sine theta. So solve it. What do you get? Sine theta gone. Push. Suck. Minus gone. So what do we have? B by a. Okay, so I guess that's it. Isn't it not very difficult, isn't it? Right. So definitely I will be helping you with the other questions also. Again, in the next video I'll be solving more problems on parametric functions. So if you have liked this video, please hit the like button, share it with your friends, and please stay safe, stay at home, and make sure that you're positively thinking good about yourselves. Be positive, don't stress out, and we are here to help you. Okay, all right then, all the best. Thank you.